To talk about matrix operations. There are three distinct matrix operations: addition and subtraction, scalar multiplication, which sounds awful but is pretty easy, and then multiplication, which sounds straightforward but has some tricks. So there are some requirements with respect to these, specifically addition and subtraction. To do this, the matrices have to have the same dimensions. Remember, dimensions, as we saw before, are the rows by the columns. For scalar multiplication, it's a moot point. We don't need to worry about it. And for multiplication, there is a special rule with respect, that's not how we spell special, at least not most of the time. There's a special rule for how we actually have to multiply them, which we'll go over when we actually talk about multiplying. So this means that if we want to actually do this, let's do an example of addition or subtraction. So please bear in mind, adding and subtracting. Adding is the same as, or should I say subtracting is the same as adding, except we're adding the opposite. So if you had two matrices, let's say 2, 3, 7, and -1, and then another matrix. Now this is a 2 by 2 matrix, right? 2 rows, 2 columns. And then if we wanted to add, then we'd have to be adding another matrix of the same dimension. So it also had to be 2 by 2. So let's say this was 0, -1, 5, and 6. To add this, now as long as the dimensions are the same, then what will happen is you're going to get a resultant matrix, a result, that is also a 2 by 2 matrix. Now, when you add these, all you're doing is adding corresponding terms. So row 1, column 1, which is this 2, plus row 2, column 2, would give you that. Then we go to row 1, column 2, plus row 1, column 2. That would give you that. And that came from 3 plus -1 equals. So then you just keep matching corresponding entries. 7 plus 5, 12. Easy. -1 plus 6, also easy. 5. Another example might be something like this. If you've got a 1, 2, 3, 4, 5, 6, this would be a 3 by 2 matrix, 3 rows, 2 columns, and we wanted to subtract then another matrix, and they had to be compatible, so this would have to be another 3 by 2 matrix. Then another way we could write that would be, so let's say that this one is 4, 5, 6, 7, 8, 9. Now the entries themselves we had to consider, so this would generate another 3 by 2 matrix, which I'm going to kind of space out a little bit. 1 minus 4 would be the first entry. And then the second entry would be 4 minus 5. So if we think of this, these are our 2 columns. Then we're going to have our rows that we'll be able to fill in. So we're going to end up with a 3 by 2 matrix, which we'll simplify over here in just a sec. But this entry would then be 2 minus 6. 5 minus 7. Simplicity in and of itself. You just have to add or subtract, whatever the appropriate operator is, in this case it's subtraction, the entries. So in this case, this would fully simplify to -3, -1, -4. I've picked a very negative matrix, haven't I? -5 and -3. So please bear in mind that when you're talking about addition and subtraction, the same rules, as long as they have the same dimensions, apply. That is, you can add or subtract in either direction. That is, you can switch the order. It's commutative, except with subtraction where it's not. You will indeed get a different answer. As a matter of fact, strictly the opposite. So if I were to subtract these two matrices in the opposite order, then I would get to the opposite of this. Now, the idea of the opposite leads us to something called scalar multiplication. Scalar multiplication is also pretty straightforward. All we're going to do is a scalar is a non-matrix. So when we talk about a scalar multiplication, we're talking about taking a matrix. So let's say we have a 3 by 4 matrix. This is going to be kind of hefty here, right? So 3 by 4 is going to have 3 rows, 1, 2, 3, and 4 columns. 4, 5, 6, 7, 8. Whoa, come back here. 9, 10. Let's undo that. Let's get rid of this. There we go. Make that look a little bit better. It's 10, 11, and 12. Scalar multiplication means we're going to take that matrix and we can what's called left row multiply or right multiply. That is, I could put the 5 here, or I could put the 5 here. Either way, I'm multiplying everything in that matrix by that number. So remember the scalar part. This is the scalar. Now, just like when we talked about scalar multiplication with a vector, a scalar is a number. It's not a matrix, not another matrix. So when we do this, the result will be the same dimensions as what we started with, except everything will get multiplied by 5. So this would be 5, 10, 15, 20. And all I do is put corresponding entries in their corresponding location. 30, 35, 40, 45. Oddly enough, because of the pattern I picked, ooh, bad, bad, not good, 45, 50, 55, and 60. So that is scalar multiplication. Now, if you choose to, you can multiply by negative numbers because those are numbers also. All it does is change the sign of whatever the appropriate entries are. We'll talk about multiplication in a separate video. It's kind of complicated.